To the Math Revision Made Meticulous video series, questions for revision for class 11 mathematics. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 50 questions for quick revision is presented at this video series, but at this video we will see first 25 questions. The steps in answers are supported by the ideas used for getting the answer. Let us start. Question number 1. Represent the set capital A, x. X is natural number and x is a prime factor of 84 in roster form. In the exam you will be given set builder form, asked to give it in roster, or give it in roster and asked to do it in set builder. A is natural number and it is a prime factor of 84. Let us list out the factors of 84. These are the factors of 84. To have a clarity, you can write it as 1 and 84, 2 and 42, 3 and 28, 4 and 21, like that, so that you will not miss out any of the factors. Out of them, the prime factors are 2, 3 and 7. Therefore, the required set is set 2, 3, 7. Let us go to question number 2. Now we have to represent the interval in set builder form. A set builder form can be converted into interval. Every interval is the set of all real numbers. Here you have been given a half open, half closed interval. Therefore it represents set of all real numbers. Interval means only real numbers between 6 and 12, such that 6 is open, therefore 6 is not included. 12 is closed, therefore 12 is included. Therefore this is set of all x such that it lies between 6 less than x and less than or equal to 12. Real number will not be 6, but it will include 12. Question number 3. You have been given a universal set and two sets are given. You have to find A union B whole dash. That is complement of A union B. Let us first find A union B, set of all elements of A and B such that the elements are not repeated more than once. For 1, 2, 3, 4, 6 and 8. A union B whole dash, what is the meaning of complement? It contains elements which are not in A union B but in the universal set. For except this 1, 2, 3, 4, 6, 8, what are the elements in universal set? They are 5, 7, 9. Therefore the answer is 5, 7, 9. The answer is 5, 7, 9. Let us go to question number 4. A is given, B is given, C is given. You have to find A cross B union C. You have to find the cross product. Step number 1. Let us find B union C. The elements of B and C such that the elements are not repeated more than once. Therefore 3, 4, 5. Now let us try to find A cross B union C. We have to find the ordered pair such that first element will be from A, the second element will be from B union C. Therefore 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5. We have to go for a problem involving domain and range. You have been given x and x plus 5 such that x is 0, 1, 2, 3, 4, 5. Let us try to find this ordered pair. Starts with x and the second element is x plus 5. Therefore 0 and 0 plus 5, 1 and 1 plus 5, 2 and 2 plus 5, 3 and 3 plus 5 and so on. Therefore the elements are 0, 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. Now what is the domain? The elements in the first position. Therefore 0, 1, 2, 3, 4, 5 is the domain. The images, that is the domain. The range is the set of all images. That is 5, 6, 7, 8, 9, 10. The elements in the second position in the ordered pair. Let us go to question number 6. A function is given. You have to find the value of this functional value f of 1.2 minus f of 1 by 1.2 minus 1. Very simple. Let us try to find all the values. Let us find what is f of 1.2. It is 1.2 whole square, 1.44, and f of 1 is 1 square. Now let us put all of them in the given expression, f of 1.2 minus f of 1 by 1.2 minus 1, for you will get the answer as 44 by 20, 2.2. Very simple. Here you are finding the functional values of the function at a particular point. Question number 7. You have to find the domain and range of the function f of x is equal to root x minus 1. Domain is the value of x which are allowed. The range is set of all images as per the given condition. Let us try to find the domain now. For the domain, you have been given square root function Therefore, a function is valid only when you have positive number inside the square root. Therefore, x minus 1 should be greater than or equal to 0. Otherwise, you will not have any image. What is the meaning of x minus 1 greater than or equal to 0? X is greater than or equal to 1. What is the meaning of x greater than or equal to 1? It is the set of all real numbers lying between 1 and infinity. That is, it goes from 1 to infinity. Therefore, this is the domain. Now, for that range, let us try to have y is equal to f of x. Let us try to have what are the values of x for this y is defined. Now, all of you know, this is square root of x minus 1, but we are taking only positive square root. Therefore, y should be a positive real number. And out of this, let us see positive real number. We have to check out whether 0 is included or not. But f of 1 is 0. Therefore, the image of 1 is 0. Therefore, the range is 0 to infinity. 0 is included and it goes up to infinity. All positive real numbers including 0. Therefore, domain is 1 to infinity, range is 0 to infinity. Therefore, to get the domain, you check out the condition for which x is defined or the function is valid for the value of x. To get the range, you check out for what values of y is defined. Well, let us see the graph of this function. You are seeing that the values of x is talking about the domain, the values of y is talking about the range. You are seeing that in the x it starts only from 1. Therefore, you are seeing that the domain is 1 to infinity. The range is it starts from 0 and goes up, therefore 0 to infinity. Well, let us go to question number 8. Prove that 3 cos square pi by 4, secant 2 pi by 3, 5 tan square pi by 3 is 29 by 2. Very simple problem. You have to check out the values of all these trigonometric functions. And first one is very simple, cos square pi by 4. But now this 2 pi by 3, it is in the second quadrant. You have to write it as pi minus pi by 3 or pi by 2 plus something. That also you can write. Now all of you know 2 pi by 3 lies in the second quadrant. Therefore, secant x will be less than 0. It will become minus secant pi by 3. And now we will write the values now. Cos pi by 4 is 1 by root 2, tan pi by 3 is root 3, and secant pi by 3 is 2 because cos pi by 3 is 1 by 2. Now we are finding all the values. Now you are taking LCM and all. You will get the right hand side as 29 by 2. Question number 9. If sin x is 12 by 13 and x lies in the second quadrant, that is 90 to 180, find the value of cos x and tan x. When sin is known, how to get cos? Using this basic trigonometric function, cos square x is square 1 minus sin square. Therefore, cos x is root 1 minus sin square. Therefore, cos x is 1 minus 144 by 169. Therefore, 25 by 169. Therefore, plus or minus 5 by 13. But you know that this is in the second quadrant. Therefore, cos x should be negative. Therefore, we have to take 5 by 13 or minus 5 by 13. We have to take minus 5 by 13. For cos x is minus 5 by 13 and tan x is sin by cos 12 by 13 by minus 5 by 13, and you are getting it as minus 12 by 5. And you are checking here cos and tan are negative in the second quadrant. Therefore, you are getting a negative answer. Well, let us go to question number 10. We have to prove that cos 4x is equal to 1 minus 8 sin square x cos square x. These are the problems involving the multiple angle formula. What is cos 4x? Cos of 2 times 2x. But we have to select the correct formula for cos 2x. Here, as per the given problem, I have to select 1 minus 2 sin square x. All the formula are same. 2 cos square x minus 1, cos square x minus sin square x, then 2 tan x by 1 plus tan square. All are one at the same. 1 minus tan square by 1 plus tan square. All are same for cos 2x. But we have to select that formula which will give this answer on the right hand side. For cos 2x, I am taking it as 1 minus 2 sin square x. Therefore, 1 minus 2 sin square 2x. Once again, let me use the formula for sin 2x as 2 sin x cos x. I am putting in place of sin 2x. Now expand it. It will become 2 into 4 sin square x cos square x. You are getting the right hand side. Question number 11. Prove that sin 10 degrees, sin 50, sin 70 is equal to 1 by 8. Then in these types of problem, we have to use the formula expressing the sum product as the sum of trigonometric function. Okay, let us now take the formula. For that, I am clubbing 10 and 50. 10 and 50 I am clubbing. Now I have a formula for 2 sin x sin y. It is cos x minus y minus cos x plus y. I am making use of that. For that I am multiplying, dividing by 2. I am using that formula cos x minus y, therefore tan minus 50 minus cos of tan plus 50 into sin 70. It becomes cos 40 minus cos 60 into sin 70. Now I can now substitute the value for cos 60. I am substituting, it is 1 by 2. Let me expand the bracket now. It is half into cos 40 sin 70 minus 1 by 4 sin 70. Once again, let me use the formula for 2 cos x sin y. It is sin x plus y minus sin x minus y. Once again, I have to multiply and divide by 2 to get that formula. Now I am applying the formula for 2 cos 40 into sin 70. It is sin 40 plus 70 minus sin 40 minus 70. Now it will become sin 110 minus sin 40 minus 70. We are continuing. And 40 minus 70 is minus 30. What is sin of minus 30? It is minus sin 30. Now I am going to make use of the formula for sin 110. Sin 110 is 180 minus 70. It is in the first quadrant, therefore sin pi minus x is sin x only. For I am making use of that 1 by 4 into sin 70. Already I am substituting the value for sin 30. It will be 1 by 2. Minus into minus will become plus. For I am getting minus 1 by 4 sin 70. Sin 70 getting cancelled. That is 1 by 4 sin 70 and minus 1 by 4 sin 70 getting cancelled. In these types of problem, always remember, you will be in a position to use the formula 2 times. At the end, the one of the value, maybe here you are getting 1 by 4 sin 70 and 1 by 4 minus 1 by 4 sin 70 getting cancelled. It will always happen in all the types of these problems. Let us move on to next question. Prove that sin x plus sin 3x plus sin 5x upon cos x plus cos 3x plus cos 5x is equal to tan 3x. Here we have to make use of the formula expressing sum as a product. For that we have to club it properly. We have to club the two functions such that their sum of their angle addition is a even number. That you have to select. For example, you select x and sin 5x, then only when you add them, x plus sin 5x is 6x divided by 2 is 3x. But when you do it, then the problem will be very simple. Therefore I am clubbing sin x and sin 5x, cos x and cos 5x, because x plus 5x is 6x. When I divide by 2, when I use the formula, you will get 3x. For that only. Okay, therefore sin x plus sin y formula is 2 sin x plus y by 2 cos x minus y by 2, and cos x plus cos y is 2 cos x plus y by 2 and cos x minus y by 2. Well, let us substitute those formula now. Therefore the first 2 sin x plus 5x by 2 cos x minus 5x by 2 plus sin 3x. Denominator 2 cos x plus 5x by 2 cos x plus 5x by 2 plus cos 3x. For in the numerator you are getting cos of minus x, it will be cos x only. For 2 sin 3x cos 2x plus sin 3x upon 2 cos 3x into cos 2x plus cos 3x. Now which can be taken outside in the numerator? Sin 3x can be taken outside. In the denominator, cos 3x can be taken outside. 2 cos 2x plus 1 will get cancelled in numerator and denominator. We are getting sin 3x by cos 3x, which is nothing but tan 3x. Let us go to a question from complex number. Find the multiplicative inverse. What do you mean by multiplicative inverse? It is 1 by that. Therefore 1 by that complex number is 1 upon root 5 plus 3i. Now we have to rationalize. Multiply and divide by root 5 minus 3i. Divide by root 5 minus 3. Multiply and divide by root 5 minus 3i. In the numerator it is root 5 minus 3i. Denominator a plus b into a minus b, a square minus b square. Therefore 5 minus of minus 9, it will become 14. Now I can write it in the x plus iy form. Therefore root 5 by 14 minus 3 by 14i. This is the multiplicative inverse. Question number 14. Express the complex number in the form x plus iy. Very simple. You have to expand the numerator. I am expanding. It is a plus b whole square. Denominator also a plus b whole square. I am expanding. A square plus 2ab plus b square. You know what is 5a whole square? It is minus 25. 3a whole square is minus 9. I am collecting the real part and imaginary part. I am getting minus 9 plus 40i by minus 5 plus 12i. What you have to do now? You have to multiply and divide by the conjugate. Minus 5 minus 12i by minus 5 minus 12i. Numerator I am expanding. Denominator, it is 25 plus 169. For denominator, I'm just writing it as, okay. Now you have to simply write the numerator by 525 by 169 minus 92 by 169i. Very simple. Okay, now let us go to question number 15. Solve the inequation 5x by 2 plus 3x by 4 greater than or equal to 39 by 4. Let us take it. Now first let us take the LCM in the left hand side. 4 is the LCM. It will become 10x plus 3x greater than or equal to 39 by 4. 4 getting cancelled. 13x greater than or equal to 39. For x is greater than or equal to 3. Now this can be expressed in the form of interval also, that is 3 to infinity. 3 is included, infinity not included. Question number 16. Find R if tan P of R plus 1 is to tan PR is equal to 30 is to 11. Here we have to use the formula for NPR. It is n factorial by n minus r factorial. For numerator is tan factorial by tan minus r minus 1 factorial by 11 factorial by 11 minus r factorial is equal to 30 by 11. Now all of you know how to convert it into multiplication. Tan factorial by tan minus r minus 1 factorial into 11 minus r factorial by 11 factorial. Here what you have to do, expand the big factorial. Therefore we have to expand 11 factorial. It can be written as 11 to 10 factorial. 11 minus r factorial is 11 minus r into 10 minus r into 9 minus r factorial. For 9 minus r factorial get cancelled, 10 factorial getting cancelled. These are all simplification of factorials. Now I am expanding the numerator. I am getting a quadratic equation, r square minus 21r plus 80 is equal to 0. I am solving it. R is equal to 16 and 5. But now in the original problem it talks with 11p something or 10p something. For r cannot be 16. R should be less than or equal to n. Therefore r is equal to 16 not possible. Therefore r is equal to 5. Let us go to question number 17. This is from permutation. Find the number of arrangements which can be made from the letters of the word Allahabad. In how many of them the vowels are always together? And question number B is starts with H and ends with D. Let us first answer the first question. Number of arrangements in Allahabad. It contains 9 letters in which A repeats 4 times and L repeats 2 times. Therefore by formula of permutation, 9 factorial by A repeating 4 times, thereby 4 factorial, and L repeat 2 times, therefore 2 factorial. Now expand the factorial. 9 into 8 into 7 into 6 into 5 by 4, 4 factorial by 4 factorial into 2. 4 factorial getting cancelled. The answer is 7560. Let us go to question number subdivision 1. Vowels are together. What are the vowels there? Only one vowel, that is capital A, but it appearing 4 times. If the vowels are together means it will be taken as a single object. For all the A will be taken as a single object. We have to first find the arrangement of these vowels. 4 A's are there, therefore it can be arranged in only one way. 4 factorial by 4 factorial, therefore 1. Now if you take it as a single element, what will happen? There will be remaining 5 letters and plus these vowels together will give you 6 objects. In these 6 objects also L repeat 2 times. Therefore 6 factorial by 2 factorial. Already vowels arrangement is 1. And by taking vowel as a single element, the arrangement is 6 factorial by 2 factorial. Therefore, the answer is 6 factorial by 2 factorial into 1. Therefore, the answer is 360. Vowels together means vowels are taken as a single object. Find the arrangement of vowels multiplied by the arrangement of the remaining objects taking vowel as a single object. Question number 2. Starts with H and N with D. Suppose when you take H and D at both the ends and 9 letters in which A repeat 4 times, H and D are fixed at extreme end. There are 7 letters left out which are to be arranged in which A appears 4 times. That is 7 factorial by 4 factorial. Now the arrangement of H and D is 1. The arrangement of the remaining 7 letters is 7 factorial by 4 factorial, which is nothing but 210. Therefore the answer is 210 into 1. Therefore 210. Let us move on to the question in combination. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways this can be done when the committee consists of exactly 3 girls? This is subdivision 1 of 18 question. Okay, 9 boys and 4 girls. How to do exactly 3 girls? 3 girl means 4 boys and 3 girls. Therefore, 4 boys from 9 boys and 3 girls from 4 girls. Therefore, 9C4 into 4C3. 9C4 into 4C1. 4C3 can be taken as 4C1 by making use of the formula NCR is equal to NCN minus R. Therefore, I am substituting the values. The answer is 504. Let us go to the second subdivision. At least 3 girls. You should be very careful. The questions will be from at least or at most. At least means start from that number, go to the maximum. At most means start from 0, go to that number. You have to remember that. Okay, well. At least 3 girls, what are the combinations? At least 3 girls means 4 boys from 9 boys and 3 girls and 3 boys and 4 girls. Therefore, it will become 9C4 into 4C3. 4 boys from 9 boys is 9C4 into 4C3. 3 girls from 4 girls is 9C3 into 4C4. And I am replacing that 4C3 by 4C1. I am substituting the values. It is 504 plus 84, which is 588. Check out all the possibilities are to be taken. Whenever R comes, you have to add, and comes, you have to multiply. Let us go to third subdivision. At most 3. This, be careful with this at least and at most. At most means you have to start with the number 7 boys and 0 girls. 7 boys, 6 boys and 1 girl, 5 boy and 2 girl, 4 boy and 3 girl. That is the meaning of at most. Start from 0, go to 3. Now these are the values which you have to be very careful. 7 boys from 9 is 9C4, 0 girl from 4 girl is 4C0, 6 boys from 9 boy is 9C6, 1 girl from 4 girl is 4C1, 5 boy from 9 boy is 9C5, 2 girl from 4 girl is 4C2, 4 boy from 9 boy is 9C4 and 3 girl from 4 girl is 4C3. I am just again changing the values. For example, 4C3 is nothing but 4C1. I am substituting the values. The final answer is 1632. Be careful with this at least and at most. Well, question number 19. You have to find x plus 1 whole power 6 and x minus 1 whole power 6, add it and evaluate root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6. This is x plus 1 whole power 6 expansion. The value of 61 is 6, 62 is 15, 63 is 20, 64 is 15 and 65 is 6. How to get this x minus 1 whole power 6? Simply alternate plus and minus. Very simple. Now you have to add them. What will happen when you add? First, second element get cancelled. Fourth element get cancelled and sixth element getting cancelled. Therefore, when you add them, you will get 2 times x power 6 and 30x power 4, 30x square plus 2. Now here you have to put one simply x is equal to root 2. When I put it, root 2 power 6 into 2 plus 30 into root 2 power 4, 30 into root 2 square plus 2. Root 2 power 6 is nothing but 8. Root 2 whole power 4 is 4. Root 2 whole square is 2. When I add all of them, I am getting 198. Question number 20. You have to use binomial theorem to evaluate 10.1 whole power 4. 10.1 whole power is nothing but 10 plus 0.1 whole power 4. Expand it. 4C1 is 4, 4C2 is 6, 4C3 is 4. And 10 cube, 10 square, 10 and 1 and 0.1 whole square, 0.1 whole cube and 0.1 whole 4. I am just using the binomial expansion. Check it out. I am now replacing the powers by a original value. 10 cube is 1000, 10 square is 100 and 0.1 is 1 by 10, 0.1 whole square is 1 by 100, 0.1 whole cube is 1 by 1000, 0.1 whole power 4 is 1 by 10,000. Cancelling it, I am getting these values. When I add them, I will get 10,406.0401. Question number 21. Find the 12th term of a geometric progression whose 8th term is 192 and the common ratio is 2. Let us first take the first term as A. R is given as 2 in the question. A8 is given as 192. What is the meaning of A8? It is A into R power 7. A into R power n minus 1 is the formula for AN. Therefore, A into 2 power 7 is 192 and A is 192 by 128. You can cancel it with 64. It will become 3 by 2. Therefore, A is 3 by 2. We want A12. It is A into R power 11. 3 by 2 into 2 power 11. 2 and 2 power 1 will get cancelled. 3 into 2 power 10. 2 power 10, all of you know it is 1024. Therefore, the answer is 3072. Question number 22. Find the sum of the first 5 terms of the series. Remember, this is a series, geometric series. For first we have to check what is the geometric series given, and we have to find what is the first term. First term is 1. We have to find the common ratio. It is second term by the first term and third term by the second term. It is coming as 2 by 3. For I got r is equal to 2 by 3 and a is equal to 1. Let us use the formula Sn a into 1 minus r power n by 1 minus r. Therefore a is 1, r is 2 by 3. For 2 by 3 power 5, 1 minus 2 by 3 power 5 by 1 minus 2 by 3. What is 1 minus 2 by 3? It is 1 by 3. For 3 multiplied by 211 by 243, and the answer is 211 by 81. Find the 3 numbers in GP whose sum is 19 and product is 216. Whenever 3 numbers are given, you should not take it as A, AR and AR square. When sum and product are given, and in 23, find 3 numbers in GP whose sum is 19 and product is 216. Here be careful. When 3 numbers are asked in geometric progression and the product and sum are given, you no need to take it as A, AR and AR square. For convenience, we have to take them as A by R, A and AR. Why? Because product is given. Okay, product is 216. A by R, A and AR product is 216. R and R getting cancelled. A cube is 216. A is 6. You have been given the sum as 19. Therefore, A by R plus AR is equal to 19. Now I can take A outside. It will be 1 by R plus 1 plus R is equal to 19. A is already got as a 6. Therefore, I am getting one quadratic equation as 6R square minus 13R plus 6. This can be solved. I am getting the values of R as 3 by 2 and 2 by 3. Now I have two values now for R. A is 6 and R is 3 by 2 and 2 by 3. The numbers are A by R, A and AR. Let me take the first set, that is 6 and 3 by 2. When I substitute there, I will get it as 469 as the 3 numbers. When I take A as 6 and R as 2 by 3, I am getting the numbers as 964. Both are one and the same, 469 and 964. Let us move on to question number 24. Find the sum of first n terms of the series. Very important. The series given is not geometric progression. You have to convert it into geometric progression. These types of problems will come in maximum 5 marks, but you should be careful. Let us take it now. Now let me take 6 outside. I will get 0.1, 0.11 and 0.111 and plus and so on to n terms. And here I will multiply and divide by 9. It will become 0.9 plus 0.99 plus 0.999 to 10 terms. Now also it is not in geometric progression. Let me write 0.9 as 1 minus 0.1. 99 is 1 minus 0.01 and so on. Now let me collect all the first terms, that is 1 up to n terms, and collect all the second term, that is 0.1, 0.01 and so on. And this is the 1 is added n time, therefore it is n. Now when you visualize the bracket 0.1 plus 0.01 but 0.001, it is a geometric progression where A is 1 by 10 and R is also 1 by 10. So let us apply the formula now. That is R A into 1 minus R power n by 1 minus R. I am substituting it, and maximum simplification you can leave it here, or otherwise you can bring that 9 inside, you can take LCM and all, you can give the answer. Question number 25. Insert 3 numbers between the numbers 1 and 256 so that the resulting sequence is a geometric progression. We are now going to have geometric means. Anyway, now when I want to introduce 3 numbers, it will become A2, A3, A4. Because A1, A2, A3, A4, 5. I want 5 numbers. Therefore, let me, when I insert this A2, A3, A4, then 1, A2, A3, A4, 256 will be in geometric progression. Now out of them A is 1 and what is A5? It is 256. Formula is A into R power 4 is 256. 1 into R power 4 is 256. Therefore R is 4. When R is 4, now I can have 1, 4, again into 4, 16, into 4, 64, into 4, 256. What are the numbers to be inserted? The numbers to be inserted are 4, 16 and 64. Okay, well, success is dependent on efforts. All the best.